Hello then, welcome to this course on data cleaning and pre-processing for banking. My name is Valentine and I'll be your instructor. In this course, we're going to be going through a set of techniques that will be important when it comes to performing data cleaning or data wrangling in an effort to prepare data for answering business questions related to just banking. So let's get started. The first thing that you need to do is to click on the description section. Just visit that section and click on the practice resource link. That should take you to a page that looks like what you're seeing on the screen. Once you get here, you can click on sample practice resource link. That should prompt you to sign in, then click on continue learning, and you should get to the sample notebook that looks like what you're seeing here. I'll be using the practice notebook, which is accessible to Afterwork members. So if you want to get access to all the challenges that you need for this particular resource, you can opt becoming an Afterwork member. Other than that, we'll be just going through the entire concept. So we'll start off with examples for each and every concept and give you the opportunity to work on the challenges. So let's get started. All right, once you get to the sample notebook, you can just connect by clicking on the far right, or you can first of all save a copy and then later on click on connect and run the prerequisite. The code that we're going to be running is this code, which will import the pandas library that we use for data manipulation with Python. Then we can get started. So the first concept that we'll go through is data type conversion, and this involves changing data types of a particular variable. So in a data set that contains many columns or variables, those variables would have what are called data types or classifications. Like we have these variables or these columns which have some sort of classification. So each one of them has those classifications. But to determine the data types, we just apply the dtypes attribute and to the data frame, and you should get now the data types on the right side. On the left hand side, we have column names. Then we might want to perform maybe some data type conversion so that we can work with the right type of data. So for instance, we might have balance, which is stored, the data there is stored in integer form, but currency or just money data would be stored in the form of a float or a decimal. So we would need to transform that into a data type that allows us to hold that kind of data, that's float. And to do that, we can use the astype function. We apply it to the column that we are interested in, and then we pass the float, the data type that we want. And that would replace our original values. So original column data type, and this would have float 64. We do the same thing with overdraft limit, which initially has integer. And then transaction count, we can also do that if we wanted to convert it to an integer, but already it has an integer data type, which is still okay. And then we can preview the first 5 records. There we go. We could have actually used d type, so let's just display the d types to confirm the conversion. So we can see balance has float 64, transaction count has in 64. There's also one more, which is overdraft limit, which has float 64. Okay, right, pause the video and then work on the challenge. Then once you're done, we can continue. Moving on, in certain cases, we might want to prepare data for further analysis, such as machine learning. And machine learning models would normally take numerical data. So we would need to ensure that the data set that we have has numerical representations. So one of the ways to ensure that is to use encoding techniques. And there are many encoding techniques. There's a popular encoding technique called one-hot encoding, and we can use this to just simply convert the categorical variables that we have into just numerical representation. So initially, if we have this data set, that contains the following data. So we have what you see here, customer information, but we have account type, branch, account status, gender, city, and country as categorical variables. If we want to convert them into numeric representations, we can use the one-hot encoding technique, and how we implement it in Python is we use the getDummies function. We pass our data frame and then specify the columns that we want to convert to have that particular numerical representations. And yeah, so that's generally what we do, and we can preview the data set, the final data set that contains now our converted data. So what you see, true or false, false would be treated by the machine learning models as zeros, and one would take place for the true values that we have there. All right, pause the video and work on the challenge, and then once you're done, we can continue. Awesome work. Moving on, in certain cases, we might want to identify duplicates in order to ensure that we are working with a data set that is clean. It doesn't have probably fraudulent records. And yeah, so how we perform that particular technique. So once we have loaded our data set, which in our case over here contains account information, we can identify duplicates using the duplicated function. So we say df, then df duplicated, then inside that duplicated function, we can set the value of the subset parameter, and that would contain the columns that we want to use for the column for the duplicate definition. So if you want to define duplicates as those records with similar account type, then we can set it as shown. But if we don't want to define it this way, maybe we want to define a duplicate as a record that contains the same value all throughout the columns, we can just leave out this particular parameter. We can just leave it out as such. But yeah, so here we're going to get records which are duplicates based on the account type, and we can preview them here. And these are the ones, like, 2 is a duplicate of these, it's a duplicate of the first record, etc. Right, pause the video and then work on the challenge. In some other situations, we might want to identify missing values and just also investigate them to see what could be the reason and probably take appropriate action. So for instance, in our case where we have this data set, again, that contains account information about customers. And if we look closely based on the first 5 records, we can see there are missing values. There's a missing value for balance, there's a missing value for phone number, and a missing value for last transaction. We can check, we can use this technique that we see here, df .is null and sum. So we use the is null and sum functions. We apply them to the data frame, and this will give us the column names as well as the respective missing records for those column names. So what you can see here, and this just tells us that in the balance column we had 5 missing values. For the zeros, it means we didn't have any missing value. Same case for phone number and last transaction date. Yeah, so that's how we can identify whether our data set contains missing values across columns. And then we can just do whatever that we want, and we'll learn how to handle missing value using 2 different techniques shortly. All right, pause the video and then work on the challenge. All right, so how do we handle missing data? So assuming again we have this data set, this is a new data set, and we determined the number of records, number of values missing across different columns. We can we can decide to maybe fill out the missing values or replace the missing values maybe with an arbitrary or constant value, maybe 0. So we would select maybe the column that we want, say balance. So here we have selected the column that we want, balance, and then we apply the fill_na function, and we specify as the first argument to that function to be the value that we want to replace with. So for missing values, we'll have 0, which will replace those missing values, and we can then set the second argument or the second parameter's value that's in place to just apply the change to original data frame. So yeah, so this, if we check this again, you'll see that balance will have 0 missing values because we've already taken care of that. So you can see that. Right, pause the video and then work on the challenge. Another technique that we can use to handle missing data is to use the mean median or mode of the existing records in that column. So assuming that we had this data set that contains customer information and it has these missing values, you can see in balance we have 8, interest rate 2. We can decide to use the mean. So we calculate the mean, let's say for balance, we store that in a variable and pass that variable to fill NA, which it's just the same approach that we used here. So only that in this case we are passing the mean, and that would replace the missing values. We can do that for the mean. We can also do that for median as well as for mode. Yeah. And if we do that, we should see that for balance and interest rate, we should see 0, 0. Yeah. All right. Pause the video and then work on the challenge. Moving on, in certain cases, we might want to filter data in order to answer some research questions, specific research questions. And there are many ways that we can use to filter for data. So one of the easiest ways is to use the query method. So assuming again that we had this data set that contains account information about customers, we might want to perform, maybe you might want to retrieve records where the column account balance, which you see here, is greater than 10,000. So how we do that is we use the query method. We apply it to the original data frame, which is the DF data frame. And then inside the query method, we specify inside quotes our condition. So this is, we have enclosed the column name in delimiter characters because we have 2 words in that column name. But if we had one, we could have just used, we could have just avoided using the delimiter characters. We say account balance is greater than 10,000 and we store that, and you can preview that just here. Right, pause the video and then work on the challenge. Okay, another way that we can use to filter for data would be to use the iloc method. The only thing here is that we are able to specify the columns that we also want, not just the rows, but the columns. So again, if we had this data set, we can use the iloc method attribute. We apply the attribute to the data frame. Then we use square brackets to specify now inside, first of all, the rows and the columns. So what we have here would represent the called position integers. So for the first, like, for the first record, it has 0. For second, it has 1, usually called position integers for that particular case. But you can use this especially for automation. You need to iterate through maybe some calculation and determine that particular filtering process using some numbers. Then you can use this approach. So for example, we want to get records 2, 3, 4. We don't get the 5th one. So from 2 to record 4. So actually, these are the records that we want. And then we want to get these columns. Column, the one that says position 0, that's the first one. Then at position 2, account holder name. At position 4, that's last transaction account. And position 6, that's branch. And yeah, that's all we do. We can filter that data and you can see it here. Okay, pause the video and then work on the challenge. In some other situations, we might want to create new features and be able to use them and to enrich our data set, to have, and that's the idea behind even creating new features. That's what, we might term as feature engineering, but feature engineering entails a whole lot, not just creating new features. There's also the idea of transforming your data. So like, changing the scale for the data that you have. There is also an idea of selecting just data that you need for your analysis. Feature engineering is quite broad, but more specifically, a type of feature engineering that we are going to showcase here is called feature construction, where we are creating new features out of existing features. So for instance, in our case, if we had this data set that we wanted to use to train on to train on maybe some machine learning model, or we wanted to use the new data to answer some research questions, we can create new features. So first of all, we can just convert the feature that we might use to create now a new feature. So let's say in our case here, we would need to ensure that our last transaction date column is in the right data type, that's date time format, because we're going to use it to create a new feature. So that's what we do here. And then we create now a new feature called days since last transaction. So this will contain the number of days since the last transaction, so which should be the result of PD timestamp. Now this will get the current time minus df transaction date, which should essentially be the date that's in the column. So this would give us the difference, but then we have that as days by applying dt.days, and that should be stored there. And then we can also create another feature for average transaction, which would be account balance divided by account transaction count. That should give us average transaction amount. And also we can create another feature called active customer, which would be either a 0 or 1. And it will be as a result of this expression that we see here. If the days since the last transaction is less than 30, we would get a 1. If it's not, we get a 0. You can preview that to see those 3 new columns. So on the far end, you can see the 3 new columns that we are working with. All right, pause the video, then work on the challenge. Lastly, we can identify outliers in our data set using a machine learning technique called isolation forest. And so if we have this data set that we see here, we can decide to use the following features. So these are just features or columns that we would want to use to identify outliers. So these are when we save them is in a features variable, and that's what we're going to give our machine learning model, which will be based off what is called the isolation forest algorithm. So here, once we have set aside those columns, those columns that we want to use to identify our outliers, then we can instantiate the isolation forest model, which you do here. Contamination just sets the percentage of records that you want to check for whether they are outliers. Random state just ensures that we get reproducible results, and normally you'd set it to 42 for just reproducibility, but the other person that you share with this work would need to also set it at 42. Contamination 0.1. Normally the value that this would have is usually 0.0, is from 0 to 0.5. And if you check the documentation, if I drag my mouse on top of isolation forest, there's some pop-up for documentation, but you could also search that. I don't know why it's refusing. If I scroll down to contamination, it's the amount of contamination, the proportion of outliers in the data set. Normally, if float is used, the contamination should be 0 to maybe 0.1, but auto normally is the default. You could also do that as well, but default is 1.0. Default is default is it's auto, because you can see default here, it's auto. We don't have to set it, but if float is used, you can change the range from 0 to 0.5. But we give the features, we give the model our features, and it learns from that and which of the records are outliers, and it predicts them here. We store them in a new column, but again, we decide it stores the outliers as -1 in the new column, but 1 would be the inliers, the normal records. So that's what, and then what we do here is just some encoding where we just replace negative ones with just outlier, 1 with an inlier, and we replace that to the original outlier column, and then we just display now our data set. And if I run this, I should be able to see now our data. But you can see this data, but if we wanted to check the outliers, we can just check the outliers, because we want to check the outlier here. So we can just use a querying method, df query, just to check the query. So query outlier, outlier is equals to string outlier. So this should give us the outlier records. which are the ones that you see here. Yeah, so these are the ones that are outliers. The rest are okay. One would need to investigate further and see what exactly makes these ones outliers. All right, pause the video and then work on the challenge. Okay, so that's it in terms of the data wrangling techniques that we thought would be useful when it comes to working on research problems pertaining to banking, more specifically in terms of data research problems. If you would want to continue this journey, we would recommend that you maybe do a bit more practice in terms of data wrangling. We have so many resources on our platform, so you feel free to also dive into those. Of course, think of maybe the option of becoming an Afterwork member. You'll get access to challenges for those resources and also solution notebooks where you can, that you can use to just verify what exactly you have come up with. Aside from that, once you've gone through that journey, you can now look towards now doing visualization work, which is the next course in this series that we're going to be posting. So yeah, so generally that's the learning journey. Then after that, we'll move on to something else, such as maybe how to do maybe loan prediction, that's classification problems, or even just customer segmentation, that's on the side of doing clustering work now, doing k-means clustering, etc. So yeah, so that's just a recommendation on what is next. Yeah, so if you did find this video valuable, be sure to give it a thumbs up. And if you'd want to be informed when we post such future learning resources, be sure to subscribe, and see you in the next video, in the next learning experience. Bye-bye.